Holy smokes.
Oh, whatever. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 276, a Mac on a Pico, ropes on the test stand, and a Battleship up on blocks. This week in the news, we wanted to start off quickly. Voyager is back online again. It's been a soap opera.
Up and down roller coaster, yeah. For something that's traveling on a straight line through space, it has a lot of curves.
Yeah, right?
I mean, it's had so many glitches over the years, which, come on, it was made in like 1973 or something like that, 1972. This most recent glitch almost looked like the end. It really didn't look good. It didn't look like we were going to get it back. It was talking gibberish, returning no sensible data at all, and they figured out it was a bad memory location and basically patched it 15 billion miles away. And hey, now all the four instruments that are still actually working on the spacecraft are back online and returning science. So yay, close call. Yeah, I kind of have mixed feelings about it. I mean, in some ways it would be really cool for it to just go out in a blaze of glory, like it, crashes into another alien probe and the two mind meld together and then they go off and they conquer the galaxy. Yeah, we all want that one. We've all seen that story. But its best case scenario is its batteries are going to die, or its RTGs are going to die, and it's just going to slowly run out of power and just go. So I'm not sure which one I like more. A definitive end because of an unrecoverable computer failure, or just the slow creep of entropy and all the power getting sucked out of it and it just becoming a cold lump of our finest 1970s technology hurtling through space for the rest of eternity. I don't know which one is better, but it's going to be one or the other.
Yikes. A little bit emo here. But
yeah,
no, totally.
I suppose.
I mean, it is true, I guess.
Yeah, I'm just glad they managed to get a little something back from it anyways. Well, I'm not even a little something. It's fully back online compared to where it was just before this. I think the whole thing started in November. We're also getting to the point where it's long outlived a lot of the people who designed it. So there's kind of nobody around to fix it anymore. And I'm still working on the design of the computer, the flight data system. The library that has the one paper that I need is still closed. They're still under construction. I every once in a while I get a ping back from them. Oh, check back with us in a couple of weeks. You know how construction goes. I'm like, yeah, sure I do. But that's still on the table, hopefully. Even if I have to take a trip to Kansas to go visit this library, I'm gonna figure this out.
Well, you know what else is back on? Hackaday IO is back on. I don't know what happened over the weekend. We've got Rich Hogben and the Supply Frame web people are looking at it, trying to figure out exactly what happened and make sure it doesn't happen again. That was really horrible. It looks like it went out late night Friday night or super early Saturday morning, and no one was in the office to fix it until Monday morning. So it was an entire weekend without IO, and made me realize how much I miss it. And also reminds me that the business card contest is going on and will be going on until July 2nd. So a couple more weeks. Get your entries in now because, yeah, what is it? July 2nd, coming down to the deadline.
There's some pretty cool entries already, so you should go check them out.
Oh, just today I saw one that was proposing to make a speaker using a flat inductor printed on flexible circuit. And I really want to see that one work. I don't think he's gotten it back from the fab house yet, so we don't have working video of it. But man, I want to see that thing work.
Yeah, I think Andy Geppert is doing a brushless motor business card. Wind your own coils. And I'm not sure what he's doing for a rotor, but it'll be interesting.
This is a journey into sound.
What's that sound?
What's that sound?
All right, well, let's head on over to What's That Sound? Last week was a brand new sound. Everyone put in their guesses. We got a little bit of foreshadowing. We got 40 answers. Of them, 37 are correct. So pressure's on, Dan Maloney.
Yeah,
Pressure's
no
on.
pressure here. Okay. Let's see. I believe that's Galaga.
Bing, da, da, da. Dan, you are in good company. You are among the
Yeah.
people who recognize Galaga. Yeah, Christina sent that one in, and I was like, "Oh, so good. I have to put it on
Yeah.
just because it's great arcade game music, actually."
Yeah, that's when arcade game music, 8-bit music was just started to get good.
Yeah, right.
I think that's the beginning of it anyways.
The three wrong answers are all, of course, era correct. There's Bubble Bobble, Pole Position, Luigi's Castle arcade game. Pole Position. I remember Pole Position as having good music, but for the
Yeah.
life of me, I can't think of it now. I'm gonna have to go look that up when the show's over.
Yeah, the Galaga music always seemed to kind of remind me of the Star Wars theme a little bit. You can kind of hear a little bit of that in the beginning, and I think that's what they were trying to go for, but
Oh, you know what my absolute favorite, hands down, from that era is Moon Patrol.
Moon Patrol.
Oh, it's pretty good.
No.
Okay, let's pick up a random number. 37. That's too high for dice. Take a picture of me, hash it. Let's see what happens. That's a classic. The winning number is 35. My God.
Whoa,
Way
that's
down
high.
toward the bottom this
Okay.
time. And that would be Dr. John, who wrote in Galaga exclamation point. Absolutely correct. Congratulations.
Can we accept the exclamation point?
I'll get in touch with you shortly, get your t-shirt size, and get a t-shirt on out to you. Everybody else, listen in next week. We'll come up with a new sound for you to guess at. Well, then let's start off the hacks. I want to start off with Aaron Christophel's new part day, a hackable smart ring. Aaron is always poking at a bunch of cheap Chinese consumer marvels, and this is no exception. It's a really sweet $20 wearable ring that's got it's a pulse sensor in the sense that it has two LEDs and it does reflective pulse measuring, and it's got an accelerometer in it. Microcontroller speaks Bluetooth LE to your phone. It's meant to be like a health wearable device, but yeah, now it can do whatever the heck you want. This one turned out to be eminently hackable. Aaron, I guess the first thing he did was he looked at the firmware update procedure, and sure enough, it doesn't have any checksums or anything like that. So in principle, you can just send whatever new firmware to it over BLE yourself. And it's as simple as that. No heavy duty hacking necessary. And I was actually over at his YouTube channel just as I was preparing up for this podcast, and he just posted a video and a GitHub link where he has written software that you can run on your cell phone and flash over the air new firmware into the Ring device. So no wiring, no soldering, no anything. Just run an app on your cell phone, push your patched firmware across. Patched firmware, how are you going to make that? The good news for this is also that the system on the chip here, the Blue X microcontroller, has an SDK available. You can just pick it up, and doesn't get easier than that. The original software hasn't been reverse engineered yet, though, so you'll have to figure out things like how to talk directly to the accelerometer. He hasn't done that yet, but he has dug up a data sheet for the SoC, and so you can see where the pinouts go. So it probably shouldn't be too impossible to do. He's also done some surgery on it by scraping away the epoxy that covers it up. He managed to expose 2 SWD pins, and so with some super fine soldering, you can actually get a wired connection to the microcontroller directly. And I guess if you absolutely needed to, you could probably sniff the traffic to and from the accelerometer, or I think you could actually just by a inspection figure out which pins the LEDs are on. That's all there is with this device. I mean, it's not got a whole heck of a lot of user interface possibilities, except as Aaron points out, it's got an accelerometer in it. So you can use it for taps or hand gestures or something like that. And I think it'd be an awesome controller for, random projects to just, wave your hand around and have the accelerometer map to sending Bluetooth LE messages to some other device of yours. So, you could tap on the ring, for instance, he suggests, you double tap. He thinks you could even probably work the accelerometer so that you could turn it and use it as a knob, like a volume knob on your ring finger. I don't know how the accelerometer versus gyro in that may make that a little bit tricky in terms of math. But, I think it'd be super fun to play around with, and $20, that's not bad. Flashing the firmware couldn't possibly be easier. So, wonders of mass production.
The first thing that occurred to me when I was looking at this is like that's not going to fit everybody. And there's no...
Right?
There's no Lord of the Rings magic where it shrinks or expands to fit the wearer. It is the size that it is. Is there a degradation of features, or do they have to take features off to make it smaller, or do they just size it for the smallest possible size? The features that are in there, the chips that are in there are set, and then they just space them out more as they grow the ring for larger sizes. I would imagine it's the latter. It's a lot of technology crammed into that one little tiny spot. I would like to see how they make it, how they do the epoxy inside like that. Do they put the flexible PCB inside of basically a circular channel and then fill the entire inside with resin and then machine away the lumen? Or do they have some kind of way to mold to that size? Whatever they're doing it so that they can still make money on it off of $20. So they've got it pretty reduced to practice, I would think, and that practice would be probably more interesting to me than the ring, because I don't know, for $20 though, why not? You pick one up and play with it.
Oh, here's a good one. Big Mac in the comments over on YouTube suggests that you could use it as a page turner for an e-reader. That'd be pretty fun. Also, you could use it for seizure detection. That actually would be super interesting. Oh, there must be tons of good applications for this, now that I think about it.
And where's the battery in this?
It's in there. There is a battery in there, and he says it runs for a day or so. That little bullseye thing is a magnetic charger. Huh.
Unless that's gold. I bet you that's going to be a corrosion issue.
Grimy. Swab it down before you charge it up. Don't go swimming in salt water.
I would strongly suggest not, yes.
Oh my God, so Arya did order them. That's awesome. This is one of those where it's like, oh, I totally need to impulse purchase order this, because every device that Aaron goes and hacks, I'm always like, oh, I totally need one of those. And I don't need a Fitbit watch. I certainly don't need a crazy little ring thing, but man, that's pretty awesome. Anywho, hats off to Aaron as usual for picking up a new piece of cheap consumer tech and digging into it. This one looked like it was particularly easy prey, but that doesn't make it any less cool to have super easy open tools to play with it yourself.
Okay, first up for me, I had to pick a brief look inside a homebrew digital sampler from 1979. And the reason I had to pick this is because it's by Mitsuru Yamada, and I've been following his work for years now. And one look at the image in this article, you'll probably recognize the beginnings of the construction technique that he uses now for things like the Perseus 8 computer. He recently built a telescope control unit. It always builds out of aluminum. It's like signature material for Mitsuru Yamada. This was built in 1979 when he was 19 years old. So he's just a couple of years older than me. And so we got that in common. The thing is, if it weren't for the somewhat homebrew looking labels that he had to use for the front panel, you'd swear this was, some sort of, commercially available piece of equipment. Basically what it is, it's a digital sampler for an analog oscilloscope. He was doing some sort of logic analyzing sort of work back in the day, and needed to build this because he just couldn't afford to buy what was commercially available at the time. And so he came up with pretty much everything that's in here is circuits of his own design. There's not the video that accompanies this article that I wrote is very short, and it's basically just a visual tour of the inside of this device. And I kind of had to poke around a little bit to find out, what was really going on in there. I looked back in some of the DMs that I've sent back and forth with him over the years, and I didn't realize at the time, but he did explain exactly that, that he had built this thing back in 1979. So I managed to kind of pull out some details about what this is, and it's related to a more recent project where he recreated the kind of the essential core of this, which is a successive approximation ADC card that he built out of basically just whatever parts he had available at the time. I mean, it's got all the bells and whistles of a professionally built piece of test gear, except that it was built by 19-year-olds in 1979 with the constraints of being 19 years old in 1979 and probably not being able to buy too many components and things that, in 1979 didn't exist anyways. It's a really cool look back in his history. And, when we look at the other projects that he's done, like the one, as I mentioned before, the Perseus and the retro computers, he has a 6502 computer that he puts through its paces, and they all have this sort of very distinctive aluminum look to them. They're all great. The fit and finish and the craftsmanship that he puts into these projects is fantastic. And you can see the progression of his skills too. With the 1979 project internally is nowhere near as fit and finished as the more recent projects, which have like this absolutely meticulous wire wrapping that he used to assemble these projects. So yeah, really, really cool to see this, and it was very, very interesting to talk to him about it, get to hear a little bit about how it came about and how this kind of informed his whole career. He said this was the beginning of my career, and it kind of launched him. And so seeing that kind of project and having him share it with us was pretty special.
It's amazing that it was made by him when he was 19, although I think back at myself at 19 and I did some crazy things that I wouldn't think a 19-year-old should be doing either. So, kudos, but nothing this neat. My God, what a beautiful build. And, a number of people mentioned it in the comments that his hand lettering, like the whole front panel is just hand lettered. And it's funny because Al just wrote a piece on, what do you do? What do you use for making front panels? Do you get them manufactured? Do you 3D print them yourself? Do you this? Do you that? Do you use water transfer? And here we have Yamada-san. I use a Sharpie. Poof, owned. a very steady hand and a Sharpie. Well, flash forward to modern era. My next article, Postmarket OS now boots on over 250 devices. Postmarket is a Linux distribution to which device support has been added to run on a bunch of cell phones. And this 250 devices number is a little bit big, but I see what they're doing. And what I guess I mean is that there are about 50 different phones that are fully supported, and the other 200 just kind of boot up. And so if you're able to talk to them over a serial terminal over the USB, for instance, you can get a working Linux up on these devices, but there isn't super good information yet about whether the displays work or whether the GPS works or, God forbid, whether the phone works on these things. The headline news here that there are 250 devices is kind of for people who want to hack around on Linux computers. If you want to use them as a phone, it's kind of more 50. But look, this is Hackaday, and people buy Raspberry Pis, which are less powerful computers than this, that don't have screens, that don't have cameras, that don't have built-in batteries, that don't have, so that old cell phone of yours, if it's one of the 200 that at least boots up with Postmarket OS, you can now possibly use it for something, and especially so if you can get Wi-Fi up and running on it. And that makes them really useful. That turns them into totally useful devices. You could use it as a web server, you could use it as a backup server, et cetera, et cetera. So I think this is really neat. And Postmarket OS is one of those that I've always been meaning to look into. And a bunch of people in the comments come in and say, hey, this is really awesome. I use it for this, that, or the other. Someone came in and said that the Samsung tablet A 9.7 inch version works beautifully. Like that works, everything works with Postmarket OS on that one. You can actually use it as a full device, but it's actually running a full Linux underneath. And that's just so appealing. Like, I don't know, I've wanted a tablet that runs Linux that I can actually like do scripting on and do stuff, computer stuff that I want to do on forever and ever. And maybe the time has come. Maybe I need to troll eBay for a little bit and see if I could pick something up that runs Postmarket OS well. That'd be really fun. It's been a long-standing sore point of mine, I guess, that we have these incredibly powerful little computers in our pockets, but then those of us who are used to using computers can't freaking use them. And there used to be there was a Python scripting language for Android for a while, and that was really awesome. And I did a bunch of things with that, and then it got discontinued and doesn't really work anymore, and that makes me sad. There is a brand new news this week of Lindroid promises true Linux on Android. It's an app that runs Linux in it. So instead of replacing the operating system, it's a simple app that runs basically Linux in a VM on your otherwise Android system. And that's a very clever way to kind of piggyback on the Android native drivers. I like that a lot. And otherwise, I wanted to throw in a link to an old article of mine, Why Aren't We Hacking Cell Phones? And this was from 2018. And it is kind of sad that it remains true that we don't see people doing hardware hacks to liberate and reuse or whatever the tremendous computing power and the handy screen and the built-in camera, my God, and all the sensors and everything that's in a modern cell phone, even like a super old one. And I guess the conclusion that came out of this Ask Hackaday was it's the software that makes it hard for everyone. And so that's where getting a working Linux on these things is tremendously, that's a huge foot in the door. You could write stupid scripts. You could run completely reasonable software on these things. It's really interesting. So enough rambling. Check out Postmarket OS.
Yeah, I mean, how many times do we say, you've got a supercomputer in your pocket, blah, 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 and from some perspectives, that's true. Certainly from the perspective of, like the Apollo guidance computer or anything like that, from those days, yeah, that is a supercomputer. And yet we just throw it away. I mean, if it doesn't go for a ride in the toilet and it manages to get all the way to the end of its useful service life, when we get bored of it, we just sort of throw it in a drawer or maybe put it on, eBay or something like that so somebody can reuse it. I don't know. I don't know what it is. I don't know what the disconnect is between, the amount that you pay for that. And I do it myself. Like I said, I got a drawer full of them myself. Maybe putting them to work with something like this would be good. But I still think it kind of is the battery that gets to them. At one point or another, the thing that tends to fail is the battery or the charging of the battery. So you're kind of left with all that hardware, but no way to really effectively power it. You're lucky and you took care of it and that kind of stuff.
Samsung Galaxy 3, Galaxy 4, replaceable batteries. I've had...
Yeah,
actually,
there's that.
It's funny, until my wife dropped it 2 weeks ago now, my phone was ancient and had gone through 3 sets of replaceable batteries now. Now the screen is black and I'm left with the forensic challenge of getting my data off of it. So looking forward to that when I get a little free time. It's actually not so bad. You can hook it up with ADB and actually just dump all the files across. It's actually no problem to get all my images and everything off of there.
Okay, next up for me, When Your Rope Is Your Life. Picked up on this one because I kind of have a history with rope, and this is referring to climbing ropes specifically. This is from Hard is Easy, and Hard is Easy looks like he's probably climbed a rock or two in his day. He goes to the Mammoth Test Labs. Mammoth makes climbing ropes. I mean, it maybe seem a little self-obvious, but you kind of want a rope in case you fall. But it's not really that simple because the wrong rope is probably worse, maybe not worse, than no rope, because no rope sometimes means a very sudden and unpleasant stop. But also the wrong rope can mean a sudden and unpleasant stop as well. If it's like, just think of like a hemp rope, like having an anchor chain or something like that. There's very little give to those ropes, and when you finally come up on the end of your free fall, and the rope starts absorbing the force, it really just does it all in one quick impulse, and that can be a huge G load that would, break ribs, break your spine, break your neck. So the video that accompanies this article is somewhat lengthy, but very interesting survey of climbing ropes and their evolution from the hemp ropes through to nylon when it was first introduced in the 30s, and the first real nylon specifically climbing ropes were introduced. I think it was in the 1950s. How they've developed over the years. The thing that I didn't understand about climbing ropes when I got into climbing very briefly, my brother is a big climber. He's been climbing since he's been in his teens. And I kind of tagged along with him, and he taught me a few things, mainly so I could get up on the rope, get up on the wall, anchor myself in, and take photographs. I wanted to, this was a cool thing to take pictures of. And I thought if I could be anchored in and take a picture of him when he falls, that'll be pretty cool. And he did. And I got a lot of cool shots of him falling. If I could find one, I'll post it. But so anyways, I had a sort of a relationship with climbing ropes, and I got to learn a little bit about, kern mantle ropes. So it's kern mantle. It's got a core of one kind of rope and a mantle, an outer sheath of another kind of material. And those can either be static or dynamic. You've got static ones that you would use to anchor something, and you don't want the rope to stretch. But then a dynamic rope would be the rope that you would actually attach yourself to, and someone would either belay you from above or from below, depending on how you're set up. If you peel, as my brother used to say, if you fall, the rope will stretch for a while before it really stops you. And the stretch is part of the features. But what was really eye-opening here and sort of gut-wrenching in a way was watching some of those ropes fail, not just in testing, but actually, obviously, in climbing. The way the climber fell dragged the rope across basically a granite knife edge, and you could see the mantle of the rope, the outer sheath, just giving way very quickly. And then each one of the interior cores, one at a time, pink, 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 and then he just peels. Now, I don't know what happened to the guy. I hope he was okay. I hope it wasn't too far of a fall. So there was a lot of work done to figure out a realistic model for that. And a lot of work done to make machines that could systematize that. And then they found out, like, okay, well, the first machine we built just didn't work at all. That didn't duplicate the conditions at all. And the measurements we got don't inform us at all. And there's a lot of really cool technology, a lot of very homemade looking stuff, a lot of tactical builds. And you can tell everybody in the place is a climber and knows very well that their engineering efforts have a very direct and substantial impact on the lives of the people who trust their equipment.
All of the rope stuff is really super interesting. And what they're working on in the end here is making an abrasion resistant dynamic rope. So Dan was talking about the nylon core ones that let you down easy. And those are fantastic for climbing when you fall, but they have one failure mode. And this was this like scrape it across the granite rock that Dan was talking about. And making them abrasion resistant, your first instinct is, well, we'll put some Kevlar in it. And they keep saying aramid, so there must be a trademark thing here. But they keep saying, your first instinct is, we'll just throw some Kevlar in it. And there are, of course, Kevlar ropes, but all the Kevlar ropes, because it really doesn't want to stretch, are static ropes. And in fact, it's awesome for static ropes. So if you want a rope that's like a steel cable, then Kevlar's super. But if you want a rope that's going to bounce when you hit the bottom, you really don't want it. And That's part of the trick here. And the tech that they have and a couple other rope manufacturers are doing the same thing is to loosely wind some Kevlar around a nylon thread and then use this kind of combo thread to make the outer sheath of this thing with. And so you get this abrasion resistant yet stretchy outer sheath. And I thought that was really cool. And like all of this testing stuff, which was really awesome, even in and of itself, is kind of all leading up to this as like the punchline or whatever. I don't know if you need it. Like some people come into the comments and they're like, well, whenever you put a rope over a hard corner, you put a pad on it anyway. And that's true. And, you know, if you're climbing in a climbing gym where you're just climbing, you know, up a straight face, or if you're going outside where there's a straight face, you don't need it because as long as you fall back and it's not like scraping as you fall on it, you're going to be fine. But people still die from rope failures. And I think it's probably the case that a lot of them have to do with scrapes over edges. So it is something that climbers have kind of just lived with for the past 30 or 40 years of dynamic ropes. But the point is that if you can afford a little bit extra weight and a little bit extra bulk, because, you know, you're putting an extra layer on the rope, it may be worth it if you're climbing in an abrasion-y type place. So I could totally see it. But anyway, I was just mostly stoked about all the experimental gear that they use to break these ropes. While turning away from life-saving ropes to the cheapest Mac emulation hardware possible. This is a bravado hack by Matt Evans. What he does here is he takes an RP2040, a Pi Pico, with its 264K of RAM, and he emulates a Macintosh 128. You know, the old school black and white Macintosh, but this is everything emulated on the Pico. And he starts off his post with, at long last, the worst Macintosh in a cheap portable form factor, which I think is lovely. But the hardware here is stripped down to the bottom. It's a couple resistors to make the VGA output work, half of a VGA cable, and that's it. I guess you need a USB on the go cable because you need to, you know, connect the USB up to your mouse and keyboard. Literally, if you can find a cutoff half VGA cable kicking around somewhere, the rest of the hardware is going to set you back like $6. And it lets you run a complete Macintosh, super early Macintosh, Mac 128, Mac 512 era Macintosh entirely on the Pi Pico. It's important to say that it is a 128. He actually goes through some interesting hacks. He doesn't have enough free memory, of course, to make a Mac 512, but it turns out that the Mac operating system runs just fine with odd amounts of RAM. And I think he ends up making kind of a Mac 192 or a Mac 208 or something. He like allocates all of the Pico's free RAM to it and can run software. That means some of the high-endest of early 80s software doesn't work on it. I guess the most requested piece of Mac hardware is, will it run Mac Paint? And unfortunately not. Mac Paint needs 512. So Mac Paint you can't run on this, but he definitely demonstrates that you can play Missile Command on it, and in fact uses that as his CPU speed benchmark. This is a really cool project, and he starts off by saying he doesn't want to dig so deep into the Mac end of things. He just wants this to be a fun project. He doesn't want to do any 68K assembler, and he just wants to treat the OS as a black box, install a Mac OS ROM, and have it run. So his target here is to do it like super minimal. Just the old Macs especially are really simple architecturally. It's got a memory map for the different devices. So like all he has to do is implement this kind of memory map on the Pi Pico, and then he can run a pre-canned ROM. Or at least that's what he thinks when he starts the project. He ends up running into a million different troubles here, and A, digging much further into the 68K assembly than he wants to, and B, learning a lot more about the early Mac operating systems, etc., etc. Never works out as you planned, but good for him, he does. And so he programs all of this initially in an emulator, and one of the offshoots of this project is called UMac, and it is, or MicroMac probably, And it's up on one of his GitHubs. You can download that and play with it. It's the entire emulation part. He had a bunch of help doing it. There are some other early Mac projects that he used. And then the last step, of course, is porting it over to the Pico hardware, which he does once he's got it working on his big computer. And that's just really amazing. It's really so cool to think of, Mac Write or whatever working off of a Pico straight onto a VGA monitor. If you don't know how far we've come, this is like touche. Touche.
Yeah, I mean, if I'm not mistaken, the 68K chip was not much smaller than the RP 2040 board itself. I mean, and probably about the same aspect ratio, right? And the fact that that one chip was one of however many that were in the Mac just kind of blows my mind. Although we say it was the crappiest Mac of all times, it was just breathtaking at the time. I remember seeing the Mac for the first time and I was like, oh yeah, geez, wow, that's something. I mean, I had just started, I think I just gotten my first PC, and it was just like, the beige box, buy it from the back of PC Magazine from some no-name, assembler, vendor, whatever. And I was just starting to get into personal computing, and then I stopped by a friend's, and she worked at she was a graphic designer, and they had a whole bunch of Macs, and they may have been 128s, they may have been 256s, I don't know. Just to see that the design of it, the all-in-one, the really crisp display, the graphical interface, the mouse and everything, and I'm thinking back to this monstrosity of a machine that I've got sitting on my desk with an old TV for a monitor, and I'm like, oh man, the leap forward that it represented when you first saw it was pretty cool.
Absolutely. And I shouldn't have said anything bad about it, because it was nothing less than groundbreaking at the time. And like I said, to have it running on the Pico is pretty awesome. There are a couple areas though where the Mac was more performant than the Pico, at least straight out the gate. One of them is memory access. And one of the coolest hacks he does here, the Pico, the RP2040, stores its program memory off in QSPI flash off board. So it's off die, and actually loading the instructions takes a lot of time. And that slows this down. I guess when he first starts doing benchmarks, it's running at about a third speed, which bums him out. He does some profiling and sees which commands in his emulator are being called frequently. And by profiling, I mean he played Missile Command for a while. And after profiling it, decides which opcodes he needs to move on board, and then puts those resident in RAM. And so, of course, this eats up a little bit of his RAM, which doesn't, I don't know, he's 64K or something. He's still got plenty of RAM if he wants to make a 128K cutoff. And so they just run significantly faster. And I think in the end, he ends up running kind of 1.5 times as fast. This is the original Mac. So his hack of moving stuff into the local memory definitely helped. And that's something anyone out there is using an RP2040 and worried about. This is something you need to be aware of, is that running instructions from the off-board flash can actually slow it down a little bit if you're pulling down a ton of new software into the onboard RAM cache. The other thing I wanted to mention here, and Matt points this out, is that he ended up writing a custom graphics output using the PIOs on the Pico, and that he thinks it's actually a particularly sweet little VGA implementation. So he says if you want to do a medium resolution VGA, this is great code to look at, and you should check that out, because he's got it super solid. And if you look at the images, they are ridiculously crisp. It's it's fully as good as the Mac was during its day, and that's because of the rock solid timing you get out of using the PIOs to do the video driving. Really cool.
Last up for me, programming robots is hard. Figuring out how to make it easier is harder. This is an article that appeared in IEEE Spectrum by Benji Holson. It caught my eye because I've had the experience of, I remember reading an article in, I'm dating myself here severely, Omni Magazine back in the 80s, and it was sort of an article about where computers were going. Okay, 1980s, pretty much nobody had a computer in their house. The whole PC revolution was only just beginning. In fact, hadn't really even begun at that point. The author took issue with the term computer people. In other words, like if you said, "Oh, I'll talk to my nephew about that. He's a computer person." He thought that was a term that was going to be obsolete in a few years' time, because we don't talk about, and this is like in 1984, 1983, around then, we don't talk about car people. Oh, I'll talk to my nephew. He's a car person. He knows how to drive a car. Well, kind of everybody knows how to drive a car. Everybody knows how to get in a car, at least. Everybody knows how to, turn on the heat in a car. You might not be a driver, but you certainly know about cars. And the analogy was, it's a technological thing in your life, and you don't make a distinction between people who know how to operate a car versus people who don't. And you wouldn't do the same thing in the future with people who know how to operate computers and who are computer people, because everybody will be a computer person. That seemed a little bit far-fetched at the time, but he ended up being right. I mean, we still talk about people who are computer people. Obviously, we're at a different level of being computer person than my mom, somebody like that. It doesn't mean that there's still a distinction between the two groups. And I think that's what he's talking about here, the non-roboticists versus the roboticists. And the terms are a little bit awkward maybe, but, and he doesn't really describe what kind of robots he's talking about. I'm assuming he's talking about, the extant robots that we have at this time that are, that we put in everyday use, like, industrial robots on a production line, things like that. But I think he also has a mind toward, the robots of the near future, that, the delivery robots and co-working robots and things like that. And basically what he's saying is the same thing as, you're not going to say computer people, you're not going to say robot people, because everybody is a roboticist and everybody is a computer person. I think that's what he's saying here. And basically he's taking issue with designing environments for programming robots that are tailored to a poorly defined group of people, because you're thinking of people as roboticists and non-roboticists. The pull quote on this is what really stuck with me. And designing a product that solves the wrong problems for a poorly defined group isn't exactly a recipe for success. You need to define the problem before you solve it. And you also need to define the group of people that you're solving it for, because you're not going to win if you put something out there that's above or below the level of the people who are actually going to be using it.
That's a tricky one, though. I mean, I know what you mean about computer people, and, to some extent, everybody's a computer person these days. But man, if you have to troubleshoot your parents-in-law's computers, we all know who is and isn't computer people at the end of the day, right? And
yeah.
And even more fundamentally, there's just people who like to screw around with programming and people who don't like to screw around with programming. And, of course, in business, there's this whole low code, no code movement going on right now to make, essentially visual programming languages like Blockly or something to do, interesting kind of business logic mostly, without requiring these people to be able to even whip anything up in Python. And I think that's really interesting. And I think that's kind of where this article's going. But then at the same time, it's like, the software has to be easy to use and not condescending and not involve extra complexity, which is, of course, dependencies on funny software and things like this. And I think that part kind of underestimates the challenge of writing a really good software framework to make this sort of stuff easy, because I think, and there's kind of an old distinction between essential complexity and non-essential complexity. And if you write your software so that it hides essential complexity, it means that the users can't do with it what they want to in the end. But if you have all of this, unessential complexity, and of course it's preventing the users from getting to do what they want to do, making these cuts, making these dividing lines is one of those things that's really hard and really, I think, use case dependent. He has an example where he wants the arm control API in this robot to be like arm to target, and then arm to target with a speed argument, and then, maybe a speed limit argument. But really what you want to do is maybe limit acceleration. And, you probably also, if it's going to work around people, want it to not clobber the people. And you probably need to have movement limits. And, there's all of these seriously kind of essentially complex issues going on with robot control. It makes me wonder how far you can push it into simple, because it is kind of essentially complex. All right, on to the quick hacks. My first one this week comes from Ben. Harmonic table keyboard brings old idea back to life, and this is a recreation of the Axis 64 keyboard, which was discontinued back in the 2000s. It's a honeycomb hex type keyboard with a crazy alternate key layout. I should say this is a musical keyboard. This is a keyboard for playing synthesizers or playing music on. And what I really like about this build is that he uses these recently made available analog key switches here. And so he can get not just speed with which you press the keys down, but also their actual position and kind of pressure against them. Seems like it would make it a tremendously expressive musical controller, in addition to being this crazy honeycomb keyboard design. Looks really interesting. Astroscale is a Japanese company. Astroscale's Address J satellite takes up-close photo of discarded rocket stage. We've got a problem with space junk, and this is an attempt to start to fix it. They have a big grant from JAXA to go up and put up their eventual space debris deorbiting satellites. And this is step one. They've gotten the satellite to maneuver to within 50 meters of a previously discarded Japanese junked rocket stage. And I presume sometime in the future, they're going to worry about figuring out how to attach to this thing and deorbit it. And bringing up the rear, France with 3D printing a bottle labeling assembly line. This is a really sweet machine from him. His videos are always fun to watch. This one has two different parts. It has a sheet feeder part and then the kind of label gluing and attaching machine part. It's really cool. You pre-print a bunch of labels and you put some glue in the thing and you turn the crank and boom, your beer bottles are labeled for you. It goes into all sorts of detail about, types of glue you might be interested in using. What I thought was interesting is when you wet the paper's got a grain, and so it has a natural curl direction, and he had to experiment with getting the natural curl direction right so that it would feed right through his machine. Anyway, a totally marvelous machine. I don't need one, but it's fun to watch it work.
Okay, first up for my quick hacks, use the ThinkPad X1 tablet's keyboard standalone. You'd think that the X1 keyboard, this was a tablet keyboard from back in the day. Connecting that would be easy, but it's not, because they had a proprietary little pogo pin sort of connector that needed to attach to the screen of a tablet. But you could put it back to use with this 3D printed and magnet contraption that takes a USB cable's connections, spreads them out into the pattern of the pogo pins, and uses little flecks of aluminum foil to make contacts, and the magnets hold it in place. Could have been done with a custom PCB, sure, but why not just quickly 3D print something? Next up, 1940s car radio receives some love. I had no idea that radios were in cars as early as the 1946 Packard that the radio mechanic is working on. But boy, there it is, and it was not tiny. It was a big old unit, complete with speaker, and it was made to go in the dashboard. I'm sure it absolutely dominated the dashboard. This thing is not yet working. This is the beginning phases of this restoration. The controls in this radio are very interesting as far as push buttons and tuning controls. More to come on that, obviously, including a lot of capacitor replacements. Finally, Homebrew Reader brings paper tape programs back to life. This one comes from David Hansel, who has some old 9-hole paper tape sitting around from the old days when you would store your programs and your data on such a medium. Wanting to get that data back off, he built a tape reader that is based on optical sensors. So it's 9 optical sensors. There's 1 track for each bit and a smaller hole for indexing. Built a motorized reel system out of basically Lego motors, a frame out of wood, and put the whole thing together with a ATmega 328 so that it would read the parallel input from the read head and translate that into code. It actually works really fast. I was surprised at how fast it was. There were some points where the tape speed had to be slowed down. I guess the Altair 8800 simulator that he's using to get this data into, Altair Basic had a limit of how fast anybody could actually type. Since this basically is just imitating a keyboard input, he had to insert some delays, and that required controlling the motor speed. Check out the video. And if you're afraid of paper cuts, you probably want to stay away from such a thing, but he seemed to get away unscathed.
All right, well, that brings us to our can't miss articles. These are long form pieces written by our own fantastic Hackaday writing staff. And I completely unashamedly will pick my own article this week. The solar system is weirder than you think. I had to write this one because over the last 6 months or so, I've been reading all of this news about new discoveries about objects in the solar system. And I was at Chaos Communication Congress, and there was this marvelous talk about the history of what we think of as planets. And combining all of these together in my head just made me personally change my conception of what the solar system is, away from kind of the grade school 9 planets orbiting the sun / 8 planets these days orbiting the sun, to this much more nuanced view of all the crazy little things that are out there. What's driving this, of course, is telescope technology and, probably camera sensors attached to the telescopes, and basically just astronomical progress. My favorite, poster child for this, of course, is the planet Pluto that we added to the list of planets in 1930 and took off the list of planets in 2006. And the Pluto story is that telescopes got good enough that you could just about image Pluto just about when it was at the closest part of its crazy elliptical orbit to us. But Pluto has this incredibly long, 270-year orbit. And a lot of that time, it's significantly further away. It's almost twice as far away from the sun. And so if we had developed that telescope technology when it was way outside, we wouldn't even seen it. And what ended up getting Pluto declassified was not that this was kind of an absurd happenstance, but that when we started getting better and better telescopes, we found hundreds and now tens of thousands of other objects in similar orbits to Pluto that we now call the trans-Neptunian objects. And the problem here is there's just so damn many of them that you can't start to give them all names. And so, boom, out you go, Pluto. Pluto's a trans-Neptunian object like all the rest of them. But I think we replace this with a more interesting, nuanced, and completely crazy view of the solar system, which is taking into account kind of what the heck is going on outside of the orbit of Neptune in the so-called Kuiper belt. And there's some crazy, strange stuff out there. Planets the size of Pluto, planets bigger than Pluto. None of them are planets. Sorry, I said that in air quotes. Damn it, I did it. Objects as big as Pluto or bigger. The one that New Horizons flew by after it flew by Pluto, Arrokoth, is just crazy. It's like 2 rocks glommed together. There's all sorts of interesting stuff out there. And there's so much more of it than we could see when we discovered Pluto that, it's just your idea of the solar system ending at Pluto or Neptune is just so wrong. It just trails out. And similarly, the asteroid belt was back when telescopes were just good enough, before they discovered Neptune, actually. They discovered a bunch of the really big asteroids, and they were planets for a while. And that's also kind of one of these happenstances of telescope technology. And so for a while they had Ceres was one, and then Pallas, and then whatever else, Vesta, Juno, the other big asteroids that were big enough that they classified them as planets in the 1800s. And then once they discovered again that there's like 1,500 of these things out there, they're like, they're not planets, those are asteroids. In much more recent times, I guess the first of the Centaurs was discovered in 77, but we haven't really seen as many of them until really recent times, kind of 2010 and on, are all of these other kind of big as an asteroid type objects that are not in the asteroid belt, but indeed kind of moving into our zone. So between Mars and Earth, and even loop in sometimes as far as Venus's orbit. And these so-called centaurs aren't very big and they move around, so they're hard to see. But with our better telescopes, we've seen tons more of them. And the Hawaiian Pan-STARRS project is looking for them, and Mauna Kea was looking for them early on. And we've now seen, how many centaurs are there? I can't remember. There's now like tens of thousands of these things categorized. So it's like the asteroid belt, but the inner solar system asteroid belt. It's asteroids, but on the inside. And then the thing that really just finally completely freaks me out, in just the last few years, 2020 to 2023 to 2024, we've discovered that the Earth actually has a couple quasi-moons, kind of moons. And these are asteroid chunks. One of them is probably an asteroid belt asteroid that we trapped, and the other is probably a chunk that got hit off of the moon and has just gotten captured by the Earth and is orbiting around us. And they're so much smaller than our moon. Nobody's going to debate about calling them moons, but we've got things orbiting the Earth that aren't the thing we're used to orbiting the Earth. And this is brand new science. This is, these things were discovered in the last 4 years. And that's just mind-blowing to me. And I think it's really interesting how our ever-improving astronomical telescopes and observation capabilities are making what used to look really cut and dried. Here are the planets and here are their orbits. And now we're like, oh, look, we've got 2 more moons than we thought we did. I mean, they're tiny, junky moons, but they're only going to call them quasi-moons. Nobody's going to admit that they're moons. Anyway, I just think it's fantastic that the more and closer we look at things out there, even in our own solar system, the crazier it is. If you told me there were asteroids orbiting the Earth, I wouldn't have believed you.
Yeah, and I mean, I had no idea that Ceres and Vesta and Pallas and Juno and all those were once considered legit planets. That's news to me. I didn't know that they numbered them in there at one point. To me, this whole thing is very much like looking at the other scale, going down scale and looking at the cell. Cells used to be real easy,
Yeah.
So cells had nuclei, or they didn't. So you had eukaryotes and you had prokaryotes. Well, it's not quite that simple. The better instruments allowed us to look closer, and the better analysis methods let you look at the biochemistry that's going on in there, and then you get this completely different picture of what's actually going on in something that you thought you had figured out stone cold not that long ago. And just the more you look, the more you find. I mean, it's real. It's you can reproduce it. You can the astronomers can point other telescopes at it, and the biologists can have other biologists look at point their microscopes at it, and yep, I see it. Yep, I see it. Okay, it's a real thing. It don't make any sense. It's like, wow, that's really weird. Yeah, you're right. I mean, the title says it all. The solar system is weirder than you think. It's also weirder than you think it can be. You just keep turning over another rock, so to speak, and you find something else that you didn't expect. It's a fascinating field. It's hard to keep up on it because the discoveries seem to be coming so fast and furious these days. Pretty rewarding, and I do like what everybody's doing out there, and the degree to which they're communicating these finds. And the speed with which they're communicating them is pretty cool.
I think your analogy to the cell is totally right. I mean, it's, in one sense, it's just scientific progress. And, reality is messier than you thought it was, when you were a kid or when you were in first semester biology. And, the deeper and deeper you dig into it, the kind of deeper and deeper you go down the rabbit hole. And I do think that's kind of, I'm not claiming anything other than that is going on here. But for me, this was just like, I don't know. I can't remember whether it was the number of the trans-Neptunians or whether it was these centaurs that just like that gave me peace with Pluto no longer being a planet. I'll admit it. I was a Pluto holdout for a while, but I am now entirely convinced that it's just random luck that it was in the right place at the right time, that we decided it was a planet. And now that we've seen that there are who knows how many, I think 3,000 something that we've given numbers to, and we know their orbits, planets that are in this range just on the outside of Neptune. It's yeah. it's a whole different world. And so I love it. I love that it's more complicated than it is on the poster on my son's wall downstairs. They're actually doing the solar system in class right now, and I could not hold myself back from telling him about all the other crazy stuff out there. And it's for sure just going to get him in trouble with his fourth grade teacher, but I don't know when is too early to tell your kids about the trans-Neptunian objects. Maybe fourth grade is too early. Maybe we should have saved this talk until he was in high school. But, whatever.
Have the talk with him.
Let me tell you why Pluto isn't a planet, son.
Yeah, years from now, he'll thank you. Remember when we had the talk, Dad? Okay, my pick this week is the jealousy-inducing Taking a Look Underneath the Battleship New Jersey by Tom Nardi. This is one of the times when a Hackaday reader actually manages to get up and out, away from the computer and into the real world and go do something cool. And Tom got us all, I think, with this one. The Battleship New Jersey, for anybody who doesn't know it, is an Iowa-class battleship from World War II. It was in service from, 1938 or 39, I think was when the keel was laid down, and it was finally taken out of service in the 1990s after having been mothballed and recommissioned a couple of times over its life. It's an amazing piece of naval history that has been lovingly preserved for many years now in Camden, New Jersey, in the Delaware River as a floating museum, a museum ship. It's a ship in water, and it's got to be maintained, as all ships in water do, even though it's not underway and doesn't suffer from the effects of being battered by the sea, or in the case of a battleship, by battle. It still needs maintenance, and recently BB-62, the Big J, was taken out of its mooring by the Camden waterfront and moved to a dry dock for hull maintenance. And Tom got a chance to go down into the dry dock and get an up-close look at the process. I don't know how he managed that. I'd like to find out if he's got connections. I've kind of had this personal goal. Like every time I see an authorized personnel only sign, I just figure that bothers me. I want to be the authorized personnel. I want to be the guy who could just, swipe a card and go inside the nuclear reactor control building or the go into the dry dock and see a battleship or something. And I've managed to, knock off quite a few of those things in my time. Through being a firefighter and EMT, you get to go some places that other people can't go. Not too many people have been in surgery who aren't patients, and I've been in a lot of surgeries, and that's, a super authorized personnel only kind of thing. But again, I think this one is one that Tom knocked out of the park in terms of getting authorized to see this. The main point of this maintenance cycle was basically hull maintenance. So they take you to the dry dock and put you in there, and before the dry dock is flooded so the ship can go in there, they place a bunch of hull blocks in very specific spots that are determined at the time the ship is designed. So the pattern of hull blocks and how they're put in, and what their height is, what their dimension is, what their carrying capacity is, all of that is carefully engineered well in advance. Like, this was done in the 1930s. So they have to lay out the hull blocks in exactly the right place. They float the ship in. It has to be in exactly the right place. In the dry dock, there's surveyors that have to take measurements with lasers and everything, and then they slowly let the water out, and this settles down onto the blocks and sits there. It could be anywhere from dozens of feet above the floor of from the floor of the dry dock to the surface of the hull, or there's places where the hull is so close to the bottom of the dry dock that you've got to crouch to get down in there. I mean, that kind of gives me the willies. I see these workers who are down there and doing the pressure washing, and I don't know what the official term for phobia of having a really heavy thing overhead like that is. I'm sure there's a phobia for it, but it seems like I have it, because that just kind of, I don't know if I'd want to do that. Obviously, it's perfectly safe, but they basically had to do repainting the hull, and that's not just like, going down to Ace Hardware and getting a couple gallons of paint. It's a huge process of cleaning and prep, patching any holes. Tom mentions that there was, the hull has something like 165 penetrations that are supposed to be there. There's things for, like, you have to take in seawater for cooling. You have outlets for, pumps. Sensors have to penetrate the hull, sonar, communications, all that stuff. There's a ton of hull penetrations. A lot of them have been, don't serve any purpose for the museum ship, but again, they can't be permanently removed. They're a liability because they could leak. So you have to do something about them, and they put these boxes over them. They weld these enclosures over that can quickly be knocked off, so that the whatever's underneath them can be exposed to the water again. And all of that had to be taken care of before the new paint goes on. And it's that classic color scheme of oxide red with a black stripe and the Battleship gray above. And she looks beautiful. Tom took some really gorgeous shots of the ship, and it looks like it was a nice day for the ship was looking good that day, and he managed to take some really, really nice shots. All kinds of really cool details. You don't realize, you'd think that a battleship with 12-inch thick bands of armor, around the waterline and around all of the important parts of the structure of the ship, or the hull of the ship, would be watertight all by themselves by virtue of having 12-inch thick skin. But no, that's not the case. Water gets in, and there's caulk all over the place. And again, it's not just, run down to Ace Hardware and get a couple tubes of latex caulk. It's all very specialized material. It has to be maintained. It has to be inspected from time to time. Hats off to Tom for getting this tour and sharing it with us. I'm jealous. I'm going to admit it. I'm going to have to step up my game and find something cool out in the world to go see.
He must have had such a good time looking at this thing. I totally agree with you. Your giant battleship up on blocks, and you're down underneath it painting it. No, thank you. No. But I don't have much to add other than Tom took some really fantastic photos here, and you should really just check those out. I love that he got the detail that they painted it, and then they had to pick it up and move it so that it was off the blocks so that they could paint the spots under where the blocks were. And he managed to somehow just get there, like by luck, during that time when they'd already done half the paint job, but not the other part. Like, what the heck? Good for him. And just taking all the cool pictures and writing the story up. That's just, yeah, good job, Tom.
Unsurprisingly, the phobia is named megalophobia, fear of large objects.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to follow the links or leave comments, head on over to hackaday.com/podcast. And if you see anything that you want us to write up, drop us an email, tips@hackaday.com. And until next week,
keep on hacking. I'm even farther away than usual.
And Louise's cat.
There had to be a grounding problem there. Insulate each one of the cases. Good times. What's his name?
There's no possible segue here.
Okay, last up for me, program. Oh my God, come on.
The other thing, what was the other thing? I had another thing, I swear I did.